Good afternoon to everyone. I hope my voice is audible
Yes, sir. Good afternoon.
and
Yes,
the
sir.
session
Yes, sir.
is thank you very much. So today we will start our session. In our previous class, we discussed about hash list search. Okay, so in our first unit, we are discussing about the searching techniques, and then we will discuss about the sorting techniques. Okay, so the searching and sorting are most very important operations. So in our day-to-day life, in many places we are the data we are searching, and then we are performing the sorting operations. So that we are going to discuss in our first unit. We already discussed about the basic searching concepts, that is the linear search and then binary search. And in our previous session, we discussed about hashed list search. So what is a hashed list search means? So it takes minimum one comparison. Okay, means the key value will be converted into address. So by applying some hashing technique, a hashing algorithm, whatever the key of the data that we are looking, okay, that key directly can be converted into address in which the data is located. So for that, we discussed some hashing methods. Okay, and then in today's class we are going to discuss about in hashed search there is a chance of collision, means more than one keys may generate same address location. In such case there is a chance of collisions. In case of collisions, how to avoid the collision? Okay, suppose if two records generates same address location, we cannot store two records in the same address location. So we need to find the next available place for the second record. So finding that next available place and storing the record in that particular location. So this is what collision resolution technique. And after that, if we have chance, we will means we have time, then we'll discuss about the sorting techniques. Okay. Now, now, okay, we discussed about what is a collision. When two keys collide at the same home address, it means that when more than one keys generates the same address, then in such case, a collision may occur. We need to find the next available location using some collision resolution techniques. So these are all the collision resolution techniques available. Okay, first one is open addressing, second one is a linked list, and the third one is a buckets concept. So in open addressing, we have four methods: linear probe, quadratic probe, pseudo random, and then key offset method. Okay, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. So before discussing about collision resolution method, we must understand some basic things. Three important basic things. What are the three things means? Based on the nature of the hashing method. Okay, uh, these things are important. The first one is a load factor, and the second one is a clustering. Okay, so again in clustering we have primary clustering and secondary clustering, and after that the collision limit. So based these three things we must understand before entering into the collision resolution method. Okay, what is load factor? Load factor means in the given list. Okay, we are going to store the data in list. Okay, in given list, how much data we can store to avoid collision resolution. It is not at all possible to fill the entire list using data if we are using the hashed list search. Okay, as a rule of thumb, a hashed list should not be allowed to become more than 75% full. Okay, compared to the linear search and binary search, why we are coming to hashed list search means to quickly find the data. It means that with minimum comparison, one or two comparisons, we can easily locate the data. That's why we are coming to hashed list search. But on the other hand, we need to sacrifice the memory space. It means that if the list is allowed to store 100 data elements, okay, we can't store all the means 100 elements in the data. Maximum we can store only 75% of data. What will happen if we try to store 100 data in the list means more collisions will occur, and again the searching will take more time. Okay, the probe will take more time. That's why it's better to store only 75% of data in the list. Then only it will be very efficient. Okay, and what is the load factor means? The load factor is in the hashed list is the number of elements in the list divided by the physical element, the size of the list, the number of list that is stored in the list, and the total size of the list. So this is what the load factor. Okay, and the second is clustering. What is clustering means?
So your voice is breaking, sir.
When we are voice is breaking.
Now it's fine, sir.
Actually, I'm taking. Okay, fine. Now the clustering. Okay, the second concept that we should understand before entering into the collision resolution techniques is a clustering. What is this clustering means? Based on the nature of the hashing algorithms. Okay, the hashing algorithm may generate clustering. Okay, we already discussed several hash functions. So what is the power of hash function? Suppose it means it will generate, it will put the given key into address, and in that particular address we will store the values. Suppose if it is has a collision means we need to apply collision resolution technique and find the next alternative place, and there we need to store the data. And we are finding such kind of place and storing the data. Okay, where the data resides, the next available location, whether the next available location is near to the home address or it is far from the home address. Based on that, the clustering will happen. Okay, clustering means nothing but it is simply a group of data. So the group of data means the group is near to the primary location, that is a home address, or it is far from the home address. Based on that, we can categorize it into primary clustering and secondary clustering. Okay, so clustering is created by collisions. Whenever a collision occurs, because of that only the clustering happens in the list. Okay, and primary clustering means the group, it groups the data around the primary address. Secondary clustering means groups the data along the collision path throughout the entire list. Okay, secondary clustering, it is scattered among in the list, and the primary clustering means it is near to the home address of the collision area. Okay, so this is what clustering. In the next slide we can find the illustration. See here, the first picture, it represents the primary clustering, and the second picture, it represents the secondary clustering. Okay, so here we are applying the hash function for the k data, and it the location is found, we stored k. Now p also generates the same address. Okay, for p also the hash function generates the same address of the k. Since k is already stored in that particular location, we cannot store p in the kth address. So what we are doing means we are trying to find the next available location. Since the next cell itself free, we are storing P in the next address of the K. Now we are trying to apply the hash function for the Q, and the Q generates a different address location. So we stored Q in different place. Now we are again trying to store the Y. Y also generates the same address of K and P, but we cannot store Y in the kth location because we already have K, and we are trying to find alternative way. The next location also P, we stored P, so it is not possible to store Y in that location also. So we are trying to find the next location, and we are storing Y after the P. Okay, now the K, P, Y all generated same home address, that is kth home address, and it is stored around the k's address. Okay, so P also near to K and Y also near to K. So this is primary clustering. Okay, what is the home address generated by K, P, Y? Okay, near to that all the K, P, Y, all the values are stored. So this is what called as a primary clustering. Now what is secondary clustering? Secondary clustering means instead of storing the value near to the home address, we will add some key factors, or we will add some constants, and we will store it in different locations in the same list. So this is what secondary clustering. Okay, see here in the second picture we have K here. Okay, and we stored K, no collision occurred. When we try to store P, P also generates the same home address as K. Now we cannot store P in the K location because we already have P there. So by applying some collision resolution technique, we are finding next available location. In that location we are storing P. In that location P. Now we are trying to store Q. Accidentally, Q generates the same address where we stored P. So we
Sir, your
cannot
voice is
store
breaking,
Q
sir.
in the P. Hello, am I audible? Hello.
Sir, your voice not clear, sir.
It's breaking so much, sir.
Okay. Suppose if it's breaking frequently, okay, please let me know. After I have a class, I'll repeat the session once again in my local machine, and I'll upload that because I'm taking session from my
Sir, now
home,
also it's
Sir,
breaking.
now.
and due to internet, now also breaking. Received any messages from my message? Hello. Hello, everyone.
Sir,
Yes,
What,
sir.
sir?
yes, sir.
Sir, your voice is breaking, sir. Please text,
This
sir.
is hi message.
Sir, it's completely breaking, sir.
We didn't understand you, sir.
Hello, all of you. Now, my voice is clear.
Yes, sir.
Sir.
Yes, sir.
Yes, sir.
Okay, fine. So let us continue the session. Suppose if it is frequently breaking at the end of the session, please let me know. I'll try to record the same session once again in my local system, and then I'll upload that video. Okay. So I'll repeat from the introduction to collisions. Okay. So before discussing about collision, we should understand three important things. The first is load factor. I'll present now. Just 1 minute. Window. Okay, I hope my presentation PPT is visible.
Yes, sir.
Okay,
Yes, sir.
fine. So first we need to first we should understand what is the load factor. Okay, so what is load factor means in a hashed list. Okay, so the number of elements that we are going to store, it must be less than the total size. So the load factor is the total element, how much we are storing in the list, and what is the total size of the list. Okay, so that is what the load factor. It must be less than or equal to the 75%. We cannot utilize the entire list to store the data. Okay, it must be less than or less than 75% load factor. And the second one is a clustering. Why clustering is happening means because of collisions. Whenever collision occurs, we are trying to find a next available free place, and in that place we are storing the collided data. Okay, because of that, clustering is happening. There are two types of clustering: primary clustering and secondary clustering. In what is primary clustering means, the collision resolution technique, it tries to find the next available memory location near to the home address. Okay, if all the data are stored near the home address means it creates primary clustering. See here in this example, the k, it generated one address and we stored the k in that location, and we are trying to store p. P also generates the same address of k. Since k already stored in that location, we cannot store k in that place. So we are trying to find next available location, and next to k we stored p. And after that, we are trying to find address for the q, and for q the generated address is somewhere far from k, and we stored k there. No issues, no collisions. When we try to store y, y also generates the same address of k, and because of that collision occurs. We cannot store y in kth location because we already have k. We try to find the next location. In the next location also p is stored, so we cannot store it there. So we try to find the next location, and y we are storing it here. So k, p, y, all the three keys generates the same home address as k, and it is stored near to the home address. Okay, whatever the home address generated by all these three data item, all these data stored near to the home address. So this is what called as a primary clustering. All the data are stored near to their home address. What is a secondary clustering means? The secondary clustering, the data is stored in different means throughout the list by adding some offset value or some key factor value with the address. The data is stored across the list. So this is what a secondary clustering. See here in this example, in the second example, k we are storing in some location, and p also generates the same address of k. So collision occurs. We are trying to find a new location using some collision resolution technique, and we stored p. Okay, and when we try to store q, okay, it also generates the same address where we stored the p. So again collision occurred. So we cannot store q in this place. We are storing the q in different place by using some collision resolution technique. If you are looking at the second picture, here the data is not stored near to the home address. Okay, it is stored in different places. It is scattered among the entire list. So this is what called as a secondary clustering, primary clustering and secondary clustering. Okay, and the third one is a collision limit. Whenever collision happening, how many number of collisions allowed? So how many number of probes we can make to search for an item? So that must be limited. We cannot keep on looking for a next available place, next available place, next available place. It is not possible to keep on searching like that. Again, it will lead to more collisions. So there must be some limit for the collision. So 2 times collision can occur or 3 times collision can occur. So like that, we need to find some, we need to fix the limit. It is very important. If there is no limit, what will happen means, again, it will become equivalent to the binary search or linear search. We need to keep on searching our entire list where the free space is available and there to store. Okay, so it will reduce the efficiency of the hashed list search. So collision limit is very important. And suppose if the collision limit reached, what we need to do means, based on the application's importance, if the application is not that much important, we can abort and again reload the data. This is one way, but most preferable way is store the data in a separate list. Means keep the list, the hash list as a primary one, and all the collided data, we can store it in a separate memory place. Okay, the very good example for this concept is a linked list collision resolution technique. Okay, so in the beginning itself, the collision resolution technique, we discussed about open addressing linked list. Linked list is one of the very good example for maintaining this. Okay. And one more important thing is, it is important to use the same algorithmic limit when searching for data. So when you're trying to store the data, if you're fixing the limit as a 3, so after the third attempt, we cannot store the data in the hash list. If you're maintaining that, when you're trying to search also, the same limit we have to maintain. After 3 attempts, okay, you can say that the data is not stored in the list. Okay, like that, we need to maintain that limit. Okay, when storing and retrieving both times. Now let us come to the collision resolution method. In collision resolution method, the first method is open addressing. What is this open addressing means? It resolves a collision in the prime area. We already discussed what is a prime area means, the home address, where we are storing the home address. So that is what prime area. Okay, and when collision occurs, the primary address are searched for an open and unoccupied element. In that place, the new data is stored. Suppose we already stored the first student details, A student details in one location. And when we try to store the B student, it also generates the same address of A, means we need to search the list for the next available location and there we need to store it. So this is what open addressing concept. In open addressing, there are 4 different methods available: linear probe, quadratic probe, double hashing, and key offset. Okay, so what is a linear probe? It is one of the simplest method. Simply add 1 to the generated address and check the second address is free or not. If it is free, store there. If it is not free, again add one more, means 1 to the current address and check for the next available place. Until we find the next available place, you keep the, means repeat the process. Okay, simply add 1 to the address. This is what linear probe. Okay, see here, in this example, here the record 070918, this record is stored in the first location. And when we try to store 166702, when we apply the hash function, it also generates the same address of the 001th record. Okay, 918 record. Okay, so same address it is generating. So we cannot store the second address here. What we are trying to do means we are adding 1. So we are trying to find the second index. But in the second index also some data is stored. Brian Devex, his data is stored in the next location. So again add 1 more record, 1 to the address. So this location is free. The third index location, it is free. And there we are storing the 166702 record. Okay, so this is what linear probe. What is the alternative way to this means? Instead of simply incrementing 1 by 1, what we can do means first attempt, first probe, we can add 1. Second probe, we can subtract 2 and check the address. Third probe, we can add 3. And fourth attempt, suppose if still there is no free space, fourth probe, subtract 4. Okay, like that also we can implement. So that is the alternative way. Okay, we can add 1, subtract 2, add 3, subtract 4. Like that also we can perform this probing. What is the advantage of this method means it is very simple and easy to implement, and data is remains near to the home address. Okay, data remains near to the home address means again it is a primary clustering. It creates primary clustering. Okay, so this is the linear probing method. The first open addressing method, linear probing method. The second one is a quadratic probing. So here what we are doing means instead of adding a 1 to the home address, what we are doing means the probe number. Okay, first probe means 1 square. Okay, that is added to the address. Suppose in that location if it is not available, second probe, second attempt, so 2 square. Okay, just squaring the probe number and adding to the address. So this is what probe square and increment it. Okay, so this is what quadratic probe. In this way we are finding the new address location, and if that new address location is free, in that place we are storing the data. The second method, that is quadratic probe. This is also one of the open addressing method. Okay, and the third one, pseudo random collision resolution. Okay, this is a double hashing method. What is a double hashing means we are applying the hashing technique and generating a new address, and since that address is creating collision, okay, in the previous examples we performed simple arithmetic operations, we added some value, but in this method we are again regenerating one more address. That's why we are calling it as a double hashing. Okay, rather than using an arithmetic probe function, the address is rehashed. Okay, so that's why here we are saying this method is a double hashing method. Okay, and advantage of this one is it prevents primary clustering. So the data is not stored near the home address. Okay, it is stored in a different place of the list. Okay, but it creates a secondary clustering. Okay, that is another point. Okay, but it prevents primary clustering. Okay, so here pseudo random collision resolution uses pseudo random number to resolve the collision. We already discussed about this pseudo random number in the hashing mechanism. Okay, in hashing mechanism also we discussed about pseudo random number generator. The same concept here we are using. Okay, here what is the difference means instead of storing means using the key as a factor. Okay, here we are using the address as a factor, the newly generated address which makes collision. Okay, that address we are taking and performing the pseudo random number generation. Okay, here example given the same, y equal to ax plus c. A and c you can take some primary numbers, and x, what is x means? X is the address which
Key.
sorry x is the address which because of that collision happened, that collided address we are taking and performing this. Okay,
So,
yes.
so in quadratic probe, do we check all types of addresses, sir? I mean, here we did 1 plus 1, we'll get 2 now, sir. As we
Yes,
go on increasing the square, the address number gets increases now, sir.
yes.
And how can we check all addresses, sir? Like,
It is not possible to check all addresses. Again, whenever we are doing it, we need to perform the modulo operation on the newly created address. We need to ensure that the newly created address is within the range. That must be always checked. Suppose if there are only 100 elements we can store, the new address cannot be more than 100. So we need to perform the modulo operation. And again, here also there is a chance of collision. Okay, so if you're looking at the table, the last
Yes,
two,
sir.
86, 86, okay, it is creating collisions here.
Yes,
Okay,
sir.
this the again, this is also not fully efficient way, quadratic probe. Okay, if the
Okay.
number of elements or number of collisions increases, again it will lead to the collisions.
Okay, sir.
Okay, so in pseudo-random collision, we are discussing now. Okay, in pseudo-random collision, the X, what is X here means it is the address because of that the collision happened. The collided address we are using here as a factor and creating the new address. So this is pseudo-random collision resolution. What is the limitation of this is all keys follows only one collision resolution path. Okay, one way the collision resolution path will be moving. Okay, so for each collision different paths will not be there. Okay, so it creates a significant secondary clustering. Okay, when we are trying to apply the pseudo random hash collision, okay, pseudo random collision creates secondary clustering. Okay, more secondary clustering will be created, and this is also one of the limitation of this pseudo random collision method. Okay, the next one is a key offset. Okay, so in key offset also double hashing method, pseudo random and key offset both are double hashing. What is double hashing? We already discussed. So we are rehashing the address. If an address makes collision, we are again calculating a new address from the old address which created the collision. Okay, and it produces a different collision path for a different case. Okay, so the previous pseudo random, it created same path. Here it creates different collision paths for different keys. Okay, and it adds a quotient of the key, means one simple example is given here, that is adding the quotient of the key divided by the list size to the address to determine the next collision resolution address. Okay, example given here, the formula offset equal to key divided by list size. Okay, and address equal to some offset value plus old address modulo list size. Why we are applying this modular list size means whenever we are calculating the new address, it must be within the range of the list. It should not go beyond the list. That must be ensured always. Okay, and here to example. Okay, and the second one in the second technique in collision resolution technique is a linked list collision resolution. The linked list concept we will study in the second unit. Okay, how to create linked list. Okay, so that we will discuss in the second unit. So linked list means what is a linked list means? The data we will create as a node. So one node will have the address of the next node. If you're taking array concept, in array concept, all the elements will be stored in a sequential memory location. Okay, so the first element is in the first address, means the second element will be in second address. Okay, and so on. So we can easily access the next element by increasing the index value. Okay, so that is the advantage of array. But in array, the size cannot be increased or decreased dynamically. So to get the dynamic feature, we can go for the linked list concept. So in linked list concept, each element will be created dynamically. So dynamically means we cannot ensure that the second element memory location is next to the first element, and the third element memory location is next to the second element. It is not possible to ensure this. So to avoid that, means to avoid scattered data, what we are doing means whenever a new memory location is created, its address we are storing in the previous elements node. Okay, so by storing the address values, one node, the first node, it will have the address of the second node. Second node, it will have the address of the third node. So this is what called as a linked list. It is equal to the arrays concept, array processing. The implementation we will discuss in the second unit. Okay, and that time you can easily understand the linked list concept. Okay, now what is the disadvantage of open addressing means it increases the probability of future collisions. Okay, in open addressing, if you're applying the open addressing, keep on for many data, it will lead to future collisions. Okay, whenever the new data is coming, again it will make collisions. Okay, so that is a disadvantage of open addressing. To overcome that, what we can do means we can go for the linked list approach. Okay, see, this is the linked list approach. Okay, here whenever a collision is happening, see here in the second 001 in the first index, Sarah details is stored. Okay, and again the Harry details, it is also making the same, means it is also making generating the same address of the first index. So we cannot store the Harry details in Sarah. Okay, Sarah already stored. What we are doing means we are creating a new node and its address we are storing in the Sarah's record. So when we try to search Harry or Chris, for sure it will be in the same linked list. So we will go to Sarah's record. Sarah's record contains the Harry record, and the Harry record contains the Chris record, address of the Chris record. So we can easily perform the searching operation. So this is what linked list approach. Instead of storing it in the main, in the primary list, these details will be stored as a separate secondary list, secondary storage. Okay. This is the advantage of a linked list. So this method uses separate area to store the collisions and chains all the synonyms together in a linked list. All the keys which generates the same address, it will be stored in a one single list. Okay, and it maintains two storage areas, prime area and overflow area. Each element in the prime area contains the additional field, that is address to the means a header node in the additional linked list. Okay, so that address will be stored in the prime area. Okay, and one important thing is the storage order. Okay, see here the storage order. First Sarah's details stored, then Harry details stored, and Chris details stored. How to maintain the order? Suppose if you are not going to perform many search operations here, okay, then the easiest way is storing the new record in the Sarah's place and moving the Sarah's place to the first record of the linked list. Okay, means inserting in the beginning, LIFO. Okay, that is the easiest approach. The correct approach means suppose if you are going to perform many search operation, then storing the list as per the key value means first record details in the first location, and a second record second location, and third record in the third location as per the key value, sequentially storing the data. So two approaches we can follow storage order. Either we can go for LIFO, last in first out, or based on the key sequence. Okay, so if you are storing the value in key sequence, then the searching will be very easy. Okay, so this is a linked list collision resolution technique. Okay, so this is the picture. Okay, so the next is the last one is a bucket hashing. So what is this bucket hashing means? Here we are assuming that for sure more than one keys will generate same address, and for same key we are increasing the number of records. Okay, so like one bucket can hold more than one record. So like that we are creating buckets. Instead of one address pointing to one memory location, here one address holding many records. Okay, we are creating buckets. So this is what bucket hashing. Okay, the keys will generate means all the keys which generate same address. Okay, that records will be stored in same bucket. So this is what bucket hashing. But here what is the disadvantage means data memory usage. Okay, many buckets will be empty and many buckets will be storing only one record or two record. The remaining places will be empty. Okay, and again it is not completely solving the collision problem. Suppose if bucket overflows, what we will do? We need to go for the previous either linked list or open addressing, any of the collision resolution algorithms we need to use. Okay, again, it is not completely solving the collision resolution problem. It simply postpones the problem. Okay, instead of a collision happening now, means in the second record and third record, when we are trying to insert fourth record, that time only the collision will happen. So this method, it simply postpones the collision. Okay, time for collision. Okay, it's not completely solving the collision problem. And finally, again, how we discussed about the hashing methods. Okay, we are not going to use any one of these methods. Mostly these methods will be combined together and used based on the applications requirement. Okay, so how much memory we are having, what is the key size, what is the address space size. Based on all these things, mostly these techniques will be combined together and used. If you say, sir, what is the best way to maintain this or avoid collisions, means the one of the best way is the linked list concept. Okay, but linked list, it has overhead, dynamically creating the memory location and organizing the data. It has its own disadvantages also. Okay, but that is one of the best method, linked list method. So these are all the collision resolution techniques. Okay, and the next concept is sorting techniques. So in our day-to-day life, perform the sorting operations. Okay, in sorting techniques, there are two types of sortings: internal sorting and external sorting. So what is the internal sorting means? You know, in computer memory, there are two types of memory available. What are the two types of memory? Can anyone answer? In computer, we have two types of memory. What are the two types of memory?
Temporary memory and permanent memory.
Temporary memory and permanent memory. Any other answers?
Primary, secondary, sir.
Yeah, temporary we will call it as a primary memory, and permanent we will call it as a secondary memory. Okay, can you tell me the device names which is called a primary memory and the device which is called a secondary memory?
RAM and hard disk.
Yeah, RAM and hard disk. RAM we will call it as a primary memory.
Main memory.
And hard disk main memory. Yeah, primary memory, main memory is RAM, and the secondary storage means hard disk, pen drive, CD disk. All these are secondary storage devices. Okay, so whenever you are trying to execute a program, okay, suppose if you are trying to play a song, the song is stored in your hard disk. First, it will be moved to your RAM, because compared to the speed of your processor, okay, your processor speed, the RAM speed will be matching. So the processor, instead of taking directly from the hard disk, taking from the RAM is easy. Okay, the speed will be matching. That's why all the data is moved to the RAM, and from RAM the processor is taking the data and processing. Okay, that's why the RAM is called as a main memory or primary memory. So whenever you are trying to execute a program, first that program must be moved to the primary memory, and from there only all the processing will happen. So based on this, we can classify the sorting techniques into two types: internal sorting and external sorting. What is internal sorting means? If all the data is in the primary memory, okay, then performing sorting of all the data means it is internal sorting. Okay, what is external sorting means? Suppose if you have 1 lakh records, it is not possible to store all the 1 lakh records into RAM. So what we will do means we will take part of the record and store it in RAM. Then we will perform the sorting. Again, you move it to the hard disk, take the second part of the record and perform the sorting. And finally, you merge everything and create a sorted record. So this is what external sorting. Internal sorting means in primary memory itself, all the records will be sorted. External means the secondary storage contains major part of the data, and we will take the data part by part into the main memory and performing the sorting operation. This is what external sorting. Okay, in internal sorting we have a number of algorithms, and external sorting we have merge sort algorithm. Okay, merge sort is one of the best external algorithm. We are not going to study all these algorithms because you are having one more course called algorithm analysis, design and analysis of algorithm. There you will study all the algorithms. In this course, we will study about only two sorting techniques, that is bubble sort and then selection sort. Only two sorting algorithms we are going to discuss in this course. Okay, so this we will continue in the next class. Okay, so any doubt in today's class? If you have any doubt, please post it in the chat window.